What's up, guys? Welcome back to the channel. Right, so as you can see here, we are finding the derivative of the exponential function. So, guys, this is a function underneath. As you can see there, it looks a bit complex, but it's really not. Now, if you are new to this channel, welcome. What you need to know is that I've done videos on what is this trigonometry and also limits. I also done videos on deriving from the first principle and videos on standard derivatives, so you can go and watch those videos on the playlist of this channel. But then if you are coming back, welcome back. You know how we do this, guys. Pause this video, try to solve this problem, and then continue and see if you're gonna find the very same problem that I find here in this video. If you do comment that you managed to find it, you can also comment. If you didn't, you can comment the mistake on your comment section, on the comment section. All right, guys, let's start. So, guys, as you can see there, now we have this expression. Let's look at our numerator there. We have 2 to the power of 3x plus 2 over 3. Now here you can simplify this. If you don't want to get confused, you can say the following before you use the formula. So you can say the following here. You can say 1 over 3. You take out this 1 over 3, and then you multiply everything with that 2, which is the exponent of 3 plus 2. So you know that now you can start uh, choosing the right formula for this one. So let's go and write our formula here. Remember, we have formulas here. So as you can see, this one has k. It has. Oh, but before we do that one, guys, there is something that we need to do. Oh, I almost forgot, guys. Almost forgot. So we need to separate this one here. As you can see, we have 3 plus 3x plus 2 as exponent. Now if you still remember exponents, let me just reminder, yes. If you still remember, we know that when the base are the same, exponents when the base are the same and they're multiplying each other, the exponent will add. For example, if we have x, right, to the power of, let's say, n, and then multiply by x to the power of n, the answer is gonna be x n plus m, right? So we need to do something here. So we can continue, simplify again, and say 1 over 3, and then just put it in the bracket, and then we can say the following. We can say we have 2 to the power of 3, as you can see, x multiplied by 2 to the power of 2. Remember, when they multiply the base will add. If you can take this one back, guys, if you can take this one back, it will take you there. Do you guys see? Then you can continue, and you can say now 1 over 3, and then this is gonna be let's start with this 2 to the power of 2. It's gonna give us 4, and that is gonna give us 2 to the power of 3x. Then let's just continue for the last time. If you multiply by 1 over 3, now this is going to be 4 over 3, and then that is going to be 2 to the power of 3x. So guys, I would advise you to simplify it this way before you start. I almost did, but I would advise you to simplify it this way before you start. Now let me just remove this reminder here. All right, let's continue. So guys, now when it's like this, now you can start selecting the formula here. So the formula for this one obviously is gonna be k, because we do have a coefficient of a base, and then we have our base here, which is gonna be a, and then we have n, the coefficient of exponent, which is x, and then we have that. And then when we find the dy over dx, remember it's gonna be n multiplied by k, and then we have a n, I mean to the power of nx natural log a. Right, so this is, we supposed to just substitute them. But remember, it's easier, guys, if we label what a is from our formula here, from our function here. In fact, if we label what a is, what n is, and what k is, let's start with k. Remember, k is the coefficient of the base, so the base here is 2. So what is multiplying a there? So k is gonna be 4 over 3. There we go. And then let's follow with n. N is gonna be the exponent. Remember, guys, you take it from the last function that you simplify, so it's gonna be 3, right? And what about a? A is our base, so a in this case is 2. So when you can manage to find these, then you are fine. You just substitute it there, guys. You just substitute it there. So let me just create a little bit of space here so that we can be able to answer this. So if we say dy, if we say dy dx of this function here, remember this is the function that we focus on. We can start now. We have n. What is our n? Our n is 3, so we can say 3. Then multiply by, let me just put a dot here, multiply, remember dot represent multiplication, by k. So this is k. What is k? K is 4 over 3. Then multiply by 8. So our a, remember, it's 2, and then we have exponent n, which is 3x, right? Then we have natural log, which is going to be 2. So as you can see here, if you continue here, this 3 and that 3, they're going to divide each other. Remember, this 3 and 3, they do that. These two numbers, they do that because they don't have the exponent of x, so it doesn't affect this one here. So we're going to be left with 4 multiplied by 2 to the power of 3 x natural log 2. Guys, this is your final answer. Do not multiply that 4 with this 2 base here. It's not allowed. Remember, the base, the exponent here has x. This one, the exponent is a number. So do not do that. Guys, it looked very challenging, but it was really not. All you needed to know is you have to simplify first before you do this one, guys. I hope this video managed to help you to understand how to deal with this type of function. And if you manage to get this, you can like the video, and also if it helped you, like the video as well, or comment that you managed to get this answer. And then you also comment if there is something that you didn't understand, or rewatch the video over and over again. It's also fine. Guys, don't forget to share this to your friends, and don't forget to subscribe to the channel if you find this as if it was helpful. Subscribe to the channel. There's more videos to come as well. At the end of this video, there is other videos that I put in a playlist where I derive from the first principle to this part here, which is part 13. You can watch those videos in a sequence order for better understanding. Thank you very much, guys, for watching. Till next time, cheers.